Hello, everyone, and welcome back to Activity 38-2. We're going to take a look at Problem 4. For those of you following along in your book, Problem 4 starts on page 560, continues on with page 561. You can see I put a little blue line here to show you the break on where it's going to be, the different pages. So you'll need to kind of flip back and forth a little bit while you're doing this. All right, so let's go ahead and read the situation. Problem 4, Kathy likes Honeycrisp breakfast cereal. Each box of Honeycrisp contains a plastic animal, a monkey, an elephant, a caribou, or a bear. And each of these four animals is equally likely to be found in any given box. Kathy's younger brother, Brian, prefers Corn Invaders breakfast cereal. Each box of Corn Invaders contains either Hero Comic 1, Hero Comic 2, or Hero Comic 3, and each of the comics is equally likely to be found in any given box. Tomorrow, Kathy will open a new box of Honeycrisp and Brian will open a new box of Corn Invaders. They will find out what prizes they have. So basically, the situation is that we have a brother and sister. They like different cereals, different toys in each cereal. And they're going to both be opening up boxes. So we want to kind of get an idea of what the sample space is going to be for this situation and what the probability is going to be for certain scenarios. All right, so the sample space is going to be two things. You got one animal and one hero, so kind of a combo of those. All right, so let's take a look. Here we have a table. So just a heads up, the rows of a table are the ones that kind of go left to right. So this would be the rows going across here. And the columns are the ones that go up and down. So maybe I'll write that, rows and columns. The way that I remember this is that columns kind of hold buildings up, right? They're those big pillars. They go up and down, so columns in a table go up and down. All right, so what we want to do is go through each of these problems. A says using an eraser, locate the cell that represents an elephant and a hero comic. So what I want to do is I want to kind of visually see what's going on. I'm going to think of elephant as being blue and hero comic 2 as being red. So the elephant is going to be represented in the rows. So any cell in this table that's in the row with elephants is going to be okay for that particular animal. And when we go to Hero Comic 2, it's going to be anything in that column. So anything in this red column represents the opportunity of getting a Hero Comic 2. Now, in this particular problem, it says represent an elephant and Hero Comic 2. So that means that it has to be both of those things happening. So the way we can see this visually is it's the intersection of the blue and the red, right? So it's going to be this purple spot right here. So when they say they want to know the cell that represents an elephant and Hero Comic 2, it's going to be this one purple cell that is at the intersection of the elephant row and the Hero Comic 2 column. Okay? Now we need to erase this to do the next problems. B, which cells of the table represent getting a caribou? So in this case, the caribou is going to be everything in the row that's labeled caribou. So those are the cells that represent caribou. And again, I got to erase this in order to do the next problem. We need to know now Hero Comic 3 for part C. They want to know the cells that represent Hero Comic 3, which would be anything in the column labeled Hero Comic 3. So any one of these cells that I've highlighted in red. Okay? And let's take a look at the next question. How many outcomes are there in the sample space for this probability experiment? Now, any one of these cells in this table is going to be an outcome that you can get. I can get a monkey and a Hero Comic 1, or an elephant and Hero Comic 3, or caribou and Hero Comic 2, or bear and Hero Comic 1, or bear comic 2, bear comic 3. Any one of these cells would represent a situation where you get one of the animals and one of the comics. So what you need to do is count them. In this case, you could sit here and go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and count them all. Or if it was a really big table, it might be a little quicker to multiply the rows by columns. 4 rows times 3 columns is 12 total possibilities. All right, so you could do it either one of the two ways, whatever you're comfortable with, but regardless of which way you do it, there are 12 possible total outcomes because that's how many of the cells we have in this table. All right, so now they want us to find some probabilities. I already wrote it down in the notation here to kind of make our life easier. In this case, they want us to find the probability of getting an elephant and Hero Comic 2. Remember that and or is important because we want to know, hey, do I need both or just one of either, elephant or Hero Comic or both of them? So in this case, again, probability kind of have that same notation, the capital P, and then in parentheses, what's going on, in this case, elephant and Hero Comic 2. We know that there were a total of 12 possible outcomes here. So that's going to be the denominator. Remember that denominator is always that total amount that you can have, in this case, 12. So now what we need to do is we need to go back up and find out how many elephants and Hero Comic 2 there are. So this kind of goes back to that first problem. I'm going to have to find, elephants, which is this row, Hero Comic 2, which is this column. And since I want the probability of and, it's going to be where both of these things happen, which is that one cell right there. Right, so there is only one cell that is both an elephant and a Hero Comic 2. So in this case, that would be our numerator, would just be the 1. It is 1 out of 12. So the probability of elephant and Hero Comic 2 is 1 out of 12. Now for part F, it's going to be the same thing, but instead of instead of and, we're going to do or. So either an elephant or Hero Comic 2. Now what's not going to change is that there are 12 possibilities. That table isn't changing. They kind of give you a little hint here. I'm not going to read that, but if you want, you can. So what we want to do is we want to now count how many there are that could be either elephant or Hero Comic 2. So again, I'm going to go ahead and you will probably do this in your head and kind of visualize where elephant is, or if you have a highlighter, you could use that. And then we're going to kind of visualize where Hero Comic 2 is. And now since it's or, it could be either just the blue highlighted area, just the red, or both blue and red. So what I want to do is count how many cells would be either blue, red, or both. So we got 1, 2, 3, 4, 5, 6. There are a total of 6 cells that are either elephant or Hero Comic 2 or both elephant and Hero Comic 2. So that's going to be our numerator. Now again, you need to reduce this. 12 and 6 have a common factor of 6. They could both be divided by 6. So 6 divided by 6 is 1. And 12 divided by 6 is 2. So in this case, the probability of elephant or Hero Comic 2 is going to be 1